Dear students, welcome to the video lecture of class hierarchy. So in object-oriented system, organize the classes into a superclass and subclass hierarchy. The different properties and behavior are used as a basis for making a distinction between the classes and subclasses. So at the top of the class hierarchy, the more general classes. At the bottom of the class hierarchy are the more specific classes. So the subclass are child classes and superclass are the parent classes. Subclass inherit from the superclass. So see this example. Here we are having a car. Car is subclass of the motor vehicle, and the family of car they inherit from the car class. So car inherit from the motor vehicle. So bus and truck and so on. So here the motor vehicle they are having subclasses: bus, truck, and car. The bus is having its own subclasses, and the truck is having its own subclasses, and car is having its own subclasses. So car is figure is a subclass of the family of car in the figure 2.4 is subclass of a car. A subclass inherit all of the properties and methods defined in its superclass. So we can drive a family of car just we have drive any car or indeed at most any motor vehicle. Subclass are generally add new methods and properties specific to the class. Subclasses are inherent from the superclass and add properties and methods are specific to the class. Subclass may refine or constrain the state and behavior inherited from the superclass. So as an example, so motor vehicle, we are having three subclasses: bus, truck, and car. And as buses are inherited from the different type of buses inherited from the bus class, and trucks are inherited from the truck class, and motor vehicle are inherited from the car class. By contrast, superclass generalize the behavior. Superclass having a behavior is general. It follows a more general state and behavior is model as one moves up in the superclass subclass hierarchy. When you go up in the superclass subclass hierarchy, you will get the generalized hierarchy, or we can say simple class hierarchy. Or more specific state is modeled as we on moved on. When you move down the superclass subclass hierarchy, then we are having a more specific behavior. For example, when you move down in the hierarchy, we are having for example, motor vehicle and bus, and bus is having a specific type of buses. Okay, so when you move down in the hierarchy, you are having a more specific classes. When you move up in the hierarchy, you are having a more general classes. Why we say it is more specific? The bus class, the subclass of bus classes, they add the attributes and methods specific to that class. That's why they are more specific when you move down in the hierarchy. It is evident from an example that the notation of the subclass and superclass is relative. A class may simultaneously be a subclass to some classes and superclass to other classes. For example, here the truck is a subclass of, at the same time the truck is a subclass of a motor vehicle, and it is a superclass for the different type of trucks. So see this example: class hierarchy of a Ford class. Okay, vehicle is a superclass, car is a subclass of the vehicle, Ford is a subclass of a car, the Mustang, Tarag, and Thunderbird are the subclasses of the Ford class. The Ford class is simultaneously the subclass for the car class and superclass for the Mustang, Tarang, and Thunderbird. So this is explain the example. Ford class define the Ford car objects. However, more specific classes of a Ford car object are Mustang, Taurus, and Escort and Thunderbird. The classes are defined Fords in a much more specific manner than the Ford car itself. The Taurus, Escort, Mustang, and Thunderbird classes are more specific classes of a Ford car. They are considered as a subclass of the class Ford, and Ford class is a superclass. The Ford class may not be the most general in the hierarchy. For instance, a Ford class is subclass of the car class. Ford class is a subclass of it is not so general, it is a subclass of a car class, which is a subclass of the vehicle class, which is subclass of the vehicle class. The car class defines how a car behaves. Next, we are going to discuss an important relationship that is known as the inheritance relationship. So the superclass and subclass, the relationship is an inheritance relationship. Why it is inheritance? Because the subclass inherit from the superclass. So inheritance is a property of the object-oriented system that allows the object to be built from the other object. Inheritance allows explicitly taking advantage of the community of the objects when constructing a new class. Inheritance is a relationship between the classes where one class is a parent class of another class. The parent class, the subclass are known as derived classes, which inherit the attributes and methods from its parent. That is, it's known as derived classes. The parent class also known as the base class. The child class also known as a derived class. The real advantage of using this technique is that we can build on what we already have. More important, reuse what we already have, because we are having a method and attributes are declared already in the in the parent class. So we are reusing it. That's why we are reusing what we already have. It leads to reusability. So see this example. So for example, the vehicle, car, Ford, when you move to the hierarchy, and Ford is having a Mustang, Taurus, and Thunderbird. So in the Mustang classes, when you pass the stop message, Mustang don't know how to respond to the stop message, because the stop method is not declared in the Mustang class, because the stop method is declared in the Ford class. So it searches, okay, it searches in the class hierarchy. The Mustang inherits the method, and as well as it apply the method. So this is the advantage of the reusability. We are defining a stop method in the Ford class. Mustang inherited it from the Ford class. So car class define the general behavior of the class. The Ford class inherit the general behavior from the car class and add the behavior specific to the Ford. It is not necessary to redefine the behavior of the car class. This is inherited. Another level down, the Mustang class inherits the behavior of the car from the car class, and then even more specific behavior of the Ford class. Mustang inherit the behavior from the car class through the Ford class, and as well as the behavior that means the specific to the Ford class. Behavior means attributes, and as well as methods are specific to the Ford class. This Mustang class add the behavior unique to the Mustang. Apart from inheriting from the parent classes, the Mustang is having the behavior unique to the Mustang classes. Assume that all Fords uses the same braking system. In this case, we stop method would be defined in the Ford and not in the Mustang class, since the behavior is shared by all the object class of the Ford. When you press a stop on the brake pedal of Mustang, you send the stop message to the Mustang object. However, the stop method is not defined in the Mustang class. So the hierarchy is searched until the stop method is found. For example, you send a message and the message is checked with a particular class. The method is not found in that class, then it will searches in the super class, immediate super class, and next level super class. It will go until the method is found. Stop method is found in the Ford class, a super class of the Mustang class, and the method is invoked. So next one is dynamic inheriting. Dynamic inheriting allows the object to change and evolve over a time. Since the base class provides the properties and attributes for the objects, changing the base class changes the properties and attributes of a class. For example, dynamically changing the parent class is known as a dynamic inheritance. If you take an example, a window object are changing into an icon and then back again back to the window object, which involves changing a base class between the window class and icon class. More specifically, dynamic inheritance refers to the ability to add, delete, and change the parent from the object or classes at runtime. When you changing the parent at runtime, that inheritance is known as a dynamic inheritance. We are changing a parent in the runtime is known as a dynamic inheritance. The variable can be declared to hold or reference object of a particular class. For example, a variable declared to a reference to a motor vehicle is capable of referring a car or a truck or any subclass of the motor vehicle. Multiple inheritance. So single inheritance means when a particular class is inherited from the only one superclass, that inheritance is known as a single inheritance. When a class is inherited from the more than one parent class, that inheritance is known as a multiple inheritance. In our OO system, object-oriented system, permit a class inherit its states, attributes, and behavior, means method from more than one superclass. This kind of inheritance is referred as a multiple inheritance. For example, a utility vehicle inherits attributes from the both the car and truck. Utility vehicle, it means actually it inherits from both truck and car. So the inheritance is known as a multiple inheritance. Multiple inheritance generally pose some difficulties. So what are the difficulties? For example, several distinct parent classes can declare a member within a multiple inheritance hierarchy. For example, in the same name, the parent classes, they have the attribute and the method and the same name. This can be an issue of choice, particularly when several superclasses define the same method. One way of achieving multiple inheritance is actually you have to inherit from the single class. Okay, inherit more appropriate class and then add an object of another class as an attribute of the given class. Okay, one class will be a part of object of one class will be part of this class, and it inherit from the more appropriate class that will be a parent class. This is the solution. Okay, thanks for watching the video.